Hello everyone, good afternoon. I am Shanmukhi Krishna Addepalli. I am working for Drones for Delivery. It's my master thesis, and my supervisor is Garcia, and the mark helped me. And from the university, Pablo Arroyo is my supervisor, and I'm from UPC Castel de Felsa. So the agenda of my project is first I start with the motivation, and then introduction. In introduction, I am going to explain about the market and the present technology available, and the problems we are taking as the challenges, and some of the solutions I am presenting for that problems, and the objective of the project, and then the execution of the project. In this you are going to see the plan, initial plan, what I am going to do, what I have planned, and then the design and the analysis of the carrier box, and I will explain how the carrier box we fixed to the drone, and the EPM, which is the heart of my project. It is a releasing technique, and how everything is worked with the mission planner. And then you are going to see the video, how it worked, and then I am going to discuss about some results and the discussions, and you are going to see some of the future improvements which I am thinking, and the cost analysis of the whole project. Okay, before going into the motivation, I am going to explain why I have chosen the HEMAV, because from the starting itself I am very much interested in drones, because I have done some projects in drones before in my engineering BTech 2, and then when I was searching for the projects, I have come across the HEMAV, and the main thing which attracted me is that this company has a good reputation and the monthly progress. There is a progressive efforts they are keeping in this company by the design, development, and constructing the drones with the new technologies and the innovation projects. Even one of my project is, despite from the Federal Aviation Administration, they have come up with this project as a challenge. So I am really happy to work with this challenging project to take up this project. And why I have chosen this project? This is the main motivation of my project, because when I came into this project, everyone, the main CEO, he showed me a lot of projects to select. But as I am a non-circuit student, I have good knowledge, and my background is from mechanical and aeronautical more than electronics. So I have taken this project because there is some mechanical work, and also which is collaborated with the electronics. So both together I have some interesting things to do with this project. So I have taken this as a challenge to work with this. What is drones for delivery? People may think that is it necessary like drones for delivery, because there are lot of other sources to deliver the products. So there are a lot of complications too to work with delivering with the drones. So but we have to think before coming the drones into the account, into our daily life, even for getting the technology of drones too, they have thought the same. But now the drones have come, are boom in the whole world. So we have to think the same way. The drones of deliveries will be the near future successive projects, because there are a lot of applications. Presently there are trial and error applications around all the world. They are showing so many experiments done with these drones. Okay, the market and the current technology available. Here around the world, once if we think some drone is coming to our field and delivering a product from the air, we really get surprised. In the same way, the Amazon is capturing the headlines nowadays. Maybe there are a lot of companies who are working on this, but the Amazon, it is capturing, because it is showing so many deliveries, like it's all experimental, because there is no legal approval from the Federal Aviation Association, but still Amazon is capturing because of its delivery process. There are a lot of deliveries it is done by with the consumer goods, electronics and medicine, and in emergency fields and in rural areas and lot more. And in the global organizations, there are much more companies who are competitive with Amazon, and other companies are Google, DHL and Walmart and many other. So, there is a survey going on this topic. This is one of the survey. If we see why, in which sector, in which markets it is more useful. So, here in this survey they have told that the medical field and has more useful this drones for delivery at present situation, and in the consumer goods with electronics and books, clothes and other stuffs, it has a second priority, and for foods and beverages it has the third priority, and so on. And if we see in the near future, if drones for delivery become in our daily lives, this may be the main reasons, because we cannot go emergency situation every day, right? It will be some situations, maybe in some disasters drones will help, but not in every day. Yes. So, if drones for delivery becomes our daily life project, then it will be more useful for gifts and electronics, food, medicines and many other stuffs according to the percentage. This is a review which is sourced by Drone Analyst. And here is the main topic, which is very interesting examples of releasing mechanism, because my project is about the releasing mechanism. So, I want to say the other companies how they are doing the releasing mechanisms, because if I want to select a releasing mechanism, I have to check with other companies too. As it is not a legal project, no one has patented their releasing mechanism. It went so hard for me to take the information, but at last I got some informations like how they are doing. The Amazon with a parachute releasing technique, and the UPS it is going with a custom van. It is nothing but the van will be in a moving mobile delivery project, and in between the destination the drone will come out of the van, and it will deliver in a near area, and it will come back to the van. This is a very good technique they are using. And the Google project wing, they are using the rope technique. It means the package is tied with a rope, and when it is at a particular altitude, the drone will release the package with the rope. It is like a safe landing, not to drop off, because we do not know what is there in the package, it depends on the package. So, it will drop safely with the rope, and when it is released, the rope will go back to the drone. And another one is Walmart. Walmart is a shopping mall, but it has come up with a very good idea of a warehouse, because the Walmart idea is to develop a warehouse for a particular areas. If there is for example, in Barcelona, it will select one area. For every particular distance, it will create a warehouse, a small warehouse. So, the drones will operate it from that warehouse only to that area. So, it is very easy and efficient to go and come back to the drones. It is like a house for the drones. Next one, problems. What we are seeing the problems and how they become challenges for us. The problems is, the first one, the person should be available to receive the package. Okay, we do not know at what time the drone will come and deliver. We have to be there at a particular place waiting for the drone for the package. And the other one, he has to be there at any weather conditions, whether it is sunny, rainy, snow, anything, the person should be available. And there is no pickup or delivery to the house, because drones cannot get into the house or apartments and deliver. So, he has to stand at outside waiting for the package. And the other one, location. We doesn't know whether the location is safe or not. Maybe the location is set by programming, okay, but at the particular time maybe some vehicle may come at the particular location, or maybe some animals may come, or anything may happen at the particular person. Maybe a person like me will be standing to steal the product, so we doesn't know. So the location is not safe. Safe maybe a yes or no. And another one is time. Drone will never wait for the time. It doesn't have the waiting time. It will drop and it will go off. So we doesn't know whether the person has taken the product or not. If the person is late, we cannot assure about the product. And the other problem is the same. The current pole, safety, thefts, these are all the weather conditions and obstacles of problems. So the solutions what we have come up is the warehouse for the self pickup and self dropping, to design a warehouse, and the drone should deliver, no, in this mainly to self pickup and self dropping, the main thing is the releasing technique. Whether the releasing technique, the electronic can do the self pickup and self dropping. And the other one, we are coming up with the container box, to design a container box so that for all the weather conditions the package will be safety and secure, okay. And the releasing technique, this is the releasing technique, the heart of the project. And the mission planner, the mission planner which designs the whole mission from the takeoff to the destination of the delivery. The next one, okay, the SWOT analysis, no, okay, the SWOT analysis. In the SWOT analysis, nothing but the strength, weakness and opportunities and the threats what for our project. So the strengths are, it is fast delivery and it can deliver in the rural areas, and there is less labor, human labor, and it increase the competitions between the companies to the companies, and because it is environmental, it helps the environmental to go green. It means if the product is delivered by the trucks and other vehicles, the CO2 emission will be more. It means it creates the pollution. But if the drones, by the drones, the go green concept will be raised again. And the weakness is the same point. What is the strength in rural areas? In urban areas it is a weakness, because in urban areas we can find the big buildings, and the drones, it is difficult for the drones to go to the particular high altitude and to deliver. And if the drone go to a higher altitude, the people who are in the low areas may complain that it's a public issues we have come across in another patents. And the people weakness is some people may some people may steal the product, and some people will shoot the drones. It is the case going on, shoot the drones when it is going through their buildings. And another thing, for startups it is very difficult for the drones to, because it costs a lot. And opportunities is as it is a new technology, there are a lot of opportunities for small scale startups to help the big industries. And threats, the Federal Aviation Association has to allow and give the license, and we don't know how much for the license it takes, the cost, and unknown date when it legally approved, we doesn't know. Objective of what my company has given me is to design a container and to develop a releasing technique. The container should hold 2 kgs, the first initial objective which they have given me, and I have to develop a mechanical actuators, and the product should be come out with a 3D model in 3D printing. And I am going to explain the report examines in the next slide. So this is my project. The initial project, the initial plan, The main two topics, and from two topics everything will fall down. The first one is to design a product, and the second one the mechanical actuators, releasing technique. So, for the design I am going to do the design in the CATIA, and to do the analysis of the design and 3D printing and fix that box to the drone. The next one, releasing technique. Releasing technique took me a lot of time because it is a very new topic for me, and for this I have to do a research work. So, first I have come up with an idea of ultrasonic piezoelectric motors. Because of poor availability of these materials, I have gone to the electropermanent magnet gripper. This has a lot of advantages I am going to explain in the next slides. And when I got this EPM, I have done with the initial tests, and then have connected to the drone, and we have collaborated with the box and the drone and the EPM to the drone with all the connections to the Pixhawk and mission planner, and then we have tested, implemented. This is the plan and duration of each topic, how much time it took for me. In this I took a lot of time for 3D printing and EPM and the literature survey. The design and analysis. From here the project starts. So, design and analysis, I have done lot of initial design specifications, everything from which suits the standard drone which they have given me, and I have first calculated all the specifications and geometric corrections from the main drone, and from that I have taken the specifications. It's all my my specifications to come up, and then I have designed, I have given all the geometry in the part design, and then I have converted the 2D into the 3D in workbench. This is the workbench. It is nothing but a CATIA, but different parts. So, this is a workbench I have done with the, it's not so tough, it's very easy once we know. And the static analysis. So, here I want to ask you a question, maybe you people may get a doubt. Once I have a design, I can go directly to the 3D printing. Why I do not need to do analysis, yes, but why I have to do the analysis? Do anyone know? Because I have a designing product, okay. I can convert the designing product to the STL file, and I can directly give to the 3D printing to get it. So, if I do not explain, you people may think that she may wasted the time of doing this analysis. So, no, this is very important for any engineering student, because if we want to do a 3D printing, we have to invest lot of money, because each material we does not know how the material works. When everything is done, if the material has some flaws, or if the material is not withstanding with our drone, so it's waste of time and it's waste of money, because we are not using a simple materials, it is very costly. And if I want to test with 2 or 3 materials like carbon fiber, nylon, or PLA or ABS, I can't give the 4 materials to do 3D printing, because it costs a lot, and each material to get a product, it takes 4 days of time. It means the material cost and the time cost, it's not simple. So, before going into the 3D printing, every design should be analyzed and get results, whether it has a yield point. Yield point is nothing but it can withstand or not in all the weather conditions with loads, and can it do the dynamic analysis and the static analysis, and everything you have to do and compare with the materials, and then you have to go to the 3D printing. Maybe because of small mistakes, the boxes, the materials will get deformed. So, to avoid that problems, and to to take advantage of the time, because the analysis will not take much time than the material 3D printing. So, keeping all this in account, we have to do the analysis. So, in this analysis, we have given the load, what is acting on the body when it is in the air, and the pressure, how it is acting compared with the drone and our container. So, here we have taken the material is PLA. The process is from the model, the design from the CATIA, we take the model and we import in the ANSYS. It is nothing but analysis software, and we do a meshing. Meshing is nothing but it is dividing the whole body into a very small elements, so that when you put a load, it will act only at the nodes. Okay, this is very important. Meshing is the main part of the analysis, and then we go to the okay. So, giving element size for meshing, and then giving the material properties. Material properties of our project is nothing but mechanical properties: Young's modulus, Poisson's ratio, shear modulus, and strength of the material and everything. So, we give all the information of our PLA, because each material have their own standard values. So, we have given our PLA material properties, and then we give some boundary conditions. Boundary conditions is nothing but constraining the product at one axis, so that we can add the load and everything. So, here the load is acting as gravitational load, because we are not giving any load, because we are attaching two aluminum rods. The aluminum rods will have taking the load, not the box. So, there is no load acting on the body, only the gravitational load, because it is flying. The another one is pressure. The pressure we have to calculate, because it should comparative with the drone pressure and the body pressure should get equalized. Yes. So, so after doing the analysis, we have come across the good results. The PLA material has a normal strength of 50 megapascals, and the result is 37.4 megapascals. It is nothing but it has a very good withstanding capacity, and the pressure, it has a very good pressure value too compared to the drone. It is 4 psi. So, this is the von Mises stress. Von Mises stress is nothing but the overall stress on the body, on the object. So, this is in this von Mises stress is nothing but we got the strength of, we calculate the strength of the material. Implementing the carrier box. First, here I have to explain you, this is the 3D printing. We have taken FDM, fuse deposition modeling. It is nothing but it works with filament, and there are different types of 3D printers which works with powders, and laser, and this work with filaments. And so, this is a filament we have taken PLA, and because of some constraints, there is a problem with the printer, and we do not want to do another trial. As I told, once if there is a mistake, we cannot do again, because it costs a lot. So, we have come up with a prototype with a plastic polymer with 2 mm. To give a strength, we have made it as a 4 mm, and we made a box. Everything is done by not by the machine, with the human, it is me. So, I have done this with my calculations and everything in the laboratory in presence of everyone. So, it is attached. Do you know how it is attached? It is not attached directly. So, there are 2 aluminum rods inside the box. So, that aluminum rods is holding the EPM down and up, and on the top it is holding this. That is the picture of aluminum rod, how it is inside the box. So, the down part, that is EPM, it is connected by the drilling machine with the help of POW, and this is the aluminum rod and the EPM, it is connected, and this is the box. There are some mechanical properties of PLA, what we have taken, the diameter of the filament, and how it works, in what temperature it works. And this one is after fixing the aluminum rods with the EPM is connected to the fix hook, and the batteries and everything is controlled by the mission planner with the transmitter and receiver. Okay, EPM. This is the heart of the project. I have struggled a lot for this EPM. So, I want to explain you how this releasing technique happened with this EPM. It is a very new technology. So, these are the two magnetic permanent it's a type of permanent magnet. There are two permanent magnets in U-shaped. So, they are kept in such a way to okay, the first, there are two sections in the permanent magnet. The one is hard material and the down one is soft material. Okay, the hard material has a high corrosivity. It means it has yes, it has 1120 kilo ampere per meter. Okay, so and the down one is low corrosivity. Okay, so what happens here when the poles are, when the two poles are same, the magnetic properties are externally flowed. The magnetic flux will be outside the magnets. When we reverse the magnet, the magnetic flow will be turned inside the, will circulate inside the magnets. It means when it is opposite, it is fixed. When it is in the aligned way, it is going out of the magnets and it can release. So, without reversing, we are connecting a coil at the end of the magnet, so that when a pulse of current is passed, it acts the same as we reverse it. Okay, when the pulse of magnet is passed, the poles will get changed. Then it will, this is the process, this is the main principle to hold and to release the package. Okay, and this one is very important because we are not sending the electric pulse for the whole mission. Only when we are grabbing the package, it is used. Only for 0.4 seconds we are giving the current. It is very less than 1 second, and at that particular seconds, 0.2 second, it is using only 400 milliamperes. Only 400 milliamperes it is using. So, it has a very good advantage and it can hold more than 10 kilograms. So, I was so surprised to see this product in the market, and I was reading, I thought this is a perfect for the project. And then what is mission planner? Okay, this is the mission planner I have used for the project. What I have worked with the mission planner is, I know to design a flight and to control everything from this, from the takeoff to the destination, all the sensors and everything, the PICSOC is connected to this mission planner software. So, this one, in this I have 3 options how to control my EPM and EPM. So, the first one is controlled by the transmitter, the another one which I have used is camera gimbal option, the another one is controlled by ground station. Okay, so what is camera gimbal? These are the connectors, and okay, there are 3 points which I have used, which to be used to control, to release, to grab and to be neutral. The first one is high position, the 3 positions. The first position is to change the pulse width modulation from 1900 to 1500. 1900 is a high PWM, and the 1500 is a neutral position. So, I have to go to 1900 and then to come back to 1500, so that it will hold the package and stay in neutral. It will not release. It will be holding for the whole mission till I give the low position. So, when the operation is done, when it landed, I have to give a low position value PWM, that is nothing but I have to go to low 1100 and I have to come back to 1500. It means it will release and it will come back to the neutral. This is the position where I use, where the EPM use the pulse of current 0.4 seconds at this position. So, this is the camera gimbal. It sounds funny, right? Camera gimbal. Okay. So, here are the servo limits, minimum and maximum. I have to change the value of minimum and maximum values, so that the as 1900 to 1500 and 1100 to 1500, and I have to go to the main screen and I have to right click and there will be an option trigger camera on now, trigger camera now, then it will release and it will grab. This is the operation I have done personally. And the another one is controlled by ground station. Here is completely programmed, not manual. Here you have to design a flight, and for my particular operation you have to select an option, do set servo, and you have to give the same options 1900 to 1500, and again do set servo, and you have to give the 1100 to 1500 for my operation. And you are going to see the video. Oi. It's here. Pau is here helping me. No, it's setting, not started. This is the flight plan. I laughed so much when it released because for a simple thing I have done, okay. There's nothing in the box, only the papers. Oh wow. I have not noticed till now. Okay. I am capturing the photos. So now results. The experiment went success and it went good. So the results are, we are here we are comparing with other companies because the survey has the companies list what they did and which company has a good results. So we are comparing with ours which got very good results. So we have to see what it is. The payload, as our EPM has a good capacity to grab the packet, to hold a very good payload, Actually, it has more than 10 kilos, but I have wrote 5 kilos, 5 kilograms more. And the range, our drone has a very good range, and the speed it has comparatively with the other drone companies, we got a very good results. And here the launching pad, we are planning to do a warehouse as a launching pad, because our project is for self pickup and self dropping. So, we do not need any human power. So, our launching pad will be a warehouse. Okay? And the delivery method. We have two delivery methods as we have seen before. One is safe landing, going and landing on the ground and dropping, and the other one is from at an altitude you can drop, and it depends on the package. If there is nothing like papers or chocolates, you can drop from an altitude. If there is something which is important like glasses or something, you have to go and do safe landing. Do not get scared seeing all this information, it is very simple, and just gathering all the informations from all we have seen now. The first one, without human power, without human power we can do grab and release at warehouses. And another one, our project did not cost a lot, we are going to see in the next slide, and it is very safe because of the container, and it is very fast, effective, efficient. And our EPM can hold, it has a what is this, immense handling capacity, and FEM is nothing but finite element analysis, which gave a very good results of the stresses, the strength of the material, and the tendency of avoiding the pollution and creating a concept of go green. And it is very useful in the medical field, and in the rural areas, and in the cold areas, in hill stations, and in disasters, if there is any disaster. And it can operated in both ways, manual and automation. Yes. The future improvements. When I was doing this, suddenly when I am writing this future improvement itself, I got one idea of the first idea. I really like this idea of to implement the solar technology in our drone, in our project, is to implement the solar panels on the drone, all the sides of the drones, and to give that power to the battery. Maybe I do not know whether how it will work, how much time it takes and everything, but it is just an idea. Maybe we can do it with the solar panels connected to the drone, container, and to give that power to the battery. And another one, carbon fiber reinforced polymer, to use this material for the carrier box, because the whole drone is made up with this material, carbon fiber. So, we can go with the same material for the container. And another one is sense and avoid technology. I want to implement, this is upcoming technology. When I was reading in some patent, it was there. It means because we are, so there are some weakness of this topic, if you remember. If there is any obstacles, or if there is any birds, wildlife, the drone may face some problem. So, this is a sense and avoid technology. If there is an obstacles around the body, around the object, it will sense and it will go in a different path to avoid that. So, this is a very good technology I have come across. And another one, to remove the drone legs and use the carrier box as the leg, so that it will reduce the weight of the drone. Yeah, it will reduce the weight of the drone. And another point, to do some design modifications again, and because I got some other modification ideas after finishing the project. So, to do again some more modifications, and to use a rubber grip, because if we take out the legs, It would be nice if we have some rubber grip down to the box, which acts like a protection and can be used in the warehouses. So that is one of my idea, and to install the camera. The next one is cost analysis. So here for each unit, as I have come across, the drone it cost 3,500 euros, and with all the including the batteries, controller, navigation system, insurance, safety components, with everything included, it's 10,000 euros. And the payload which we have used, the PLA material for 3D printing, it's 200 euros, but we have not done with that. So we have gone to the polymer, the plastic, it's 10 euros, and the EPM is 55 euros. So total with this, it's 10,250 euros for one unit. So if we take 10 units together, if we want to build 10 units with the same concept, it will be around 1 tens, 100, 1000, 10,000, 1 lakh, 1 lakh euros for 10 units. Then annual cost, because each drone has a lifetime of 4 years, the annual cost will be around 2,500 euros per year. Yeah, it's annual. So human operations, as it is a research project and only by one person, it took 4 to 5 months to complete the project. Now we have all the information and we have all the equipments and we know all the idea. So now it will be it will take hardly 15 to 20 days to do the analysis and to fix everything. So if there is a team like 2 to 3 persons, it may take more or less time. So thank you. I'm scared.
I will make some comments later.
Okay. Okay. Any questions?
How much?
I think you all forgot the topics. I will go to my agenda again.
And every package must have some magnet or some iron?
No, as I have shown you, there will be a steel plate. Oh, there is no package photo. Oh, sorry. There will be a steel plate.
How much is it? It's in the cost? Because it's
no, it's a package with the EPM. Because that steel plate will attach the EPM. So it is the package, everything is packed.
Imagine that Amazon is shipping books, and each book must have one.
No, the package will have.
So
in the package, anything will be.
You can reuse the package.
Yes.
So the user should return the package? So
but it doesn't cost much. The steel plate, it will be less than €1.
It's just 20 cents.
Yes, the 20 cents. It's.
Maybe you should put this on the cost prices.
Yeah, okay.
But
Yes.
it's an extra cost, but it's not so much.
Okay. Yes.
Open question.
Open question.
Yeah, like you comment before, like one of the problems is like the drone doesn't know if you take the package or not. Did you think something about how to solve that?
Yes, the camera installation. The camera installation is nothing but when the drone is my concept is to work from the warehouse, right? So it delivers in the warehouses and it will recollect from the warehouse. So when in the warehouse there will be different departments. So when the package is released, the camera will take a picture and send to the customer or to the company where it is working from. So for that reason, for stealing and other damages of the packages, I have come up with that camera installation concept. Yes.
Priya.
Thank
Thank
you.
you.
Thank you. You want to ask a lot of questions to me,
No,
right?
I don't.
No, before starting the presentation, he scared me.
No, the only thing I wanted to ask is the principle of the magnets, but
Ah.
it's very well explained. So
Oh, thank you. Okay, thank you.
Priya?
Thank you.
Priya,
Yes,
do
yes,
you
yes.
know if you have certain time to give your presentation? When you give it to the teacher or within
What?
workshop?
Sí, bueno.
Sí, no sé com es diu.
okay.
What? I didn't get.
Quan fas que la presentació, quan el temps ha de durar el màster? Teniu temps obert?
How long it has to be the presentation?
Yeah.
How much?
How many time do
How
you
long?
have?
Because now,
40 minutes? 35 to 40 minutes?
well,
No.
now was
Are
like
you sure
40
about
minutes.
that?
40
I have
minutes?
the time.
No,
Ah.
Are you
45.
sure about that?
Well, ara fa 45, però amb les
I think I have started 10 minutes late.
Yes.
Yeah,
Okay.
but
Yes.
you know if you have certain time to the presentation of the university or not?
Yes, yes, I think 35 minutes. They told me 30 minutes for the presentation and 10 to 15 minutes for the questions.
Right.